Hello, I'm Dr. Dave Byers. I'm president of Quadrix Aviation. We provide airport development services to airports throughout the country, and especially in the financial planning area. Today we're going to talk about guidance on preparing benefit cost analyses as part of the university design competition. A little bit of what we're going to talk about today is just an overview of the design competition itself, the various technical approaches, the purpose of the benefit cost section, how to prepare cost data and also benefit data as well. So the design competition itself addresses specific airport needs. So the technical design challenges, and it's in the guidance book, airport operations and maintenance, runway safety, runway incursions and excursions, airport environmental interactions, and airport management and planning. Each one of those has a particular approach that your team may want to consider. The general outline of the submittals themselves, the problem statement, background, the literature review, problem solving approach, the safety risk assessment, which there's another video that describes what that's about, a description of the technical aspects of your proposal, the interaction of airport operators and the industry, which is important, and the impact of your design, and that also includes the benefit cost assessment. So why is the cost benefit in the design competition? So the section should address the commercial potential of your design, including a description of the processes that would need to be undertaken to bring the design to the product implementation state. So in essence, you're building a business case for your particular design approach. So the emphasis should be on increased affordability and utility opposed to the way things are done now, and to provide a financial analysis that reflects a realistic approach to the projected cost benefit determination and your team's design. So guidance for acceptable cost benefit analyses for the purpose of the competition is provided on the competition website. So why is a cost benefit determination part of the submittal? Is it practical? Does it solve a problem? Is it realistic? Does it make sense? Is it affordable? Is it reasonable? As far as utility, does it save time and money? Is it comprehensive? Did you consider everything? So picture your team pitching to the Shark Tank. Is your solution unique? Why you? Why should we pick you? How much do you need to develop a beta prototype? Thinking that through in terms of funding. How much do you think it'll cost per unit to make? Factoring in your research and development, materials, labor, and anything else that you can think of. How much do you think you could sell it for per unit? A rule of thumb is to use 3 times the cost to cover your margin and profit. And also, how many airports do you think could use your solution? So starting off, the very first aspect of this is the research and development, which is essentially what you're doing as part of the design competition. So the work that you're doing now to consider what approach you're going to take, what technical approach you're going to take, how much time have you spent on getting the design submittal in place? So we would want you to track your time just to get a sense of just how much effort that you put into it. Also track your materials and if you have travel, anything else that you can think of that was associated with you preparing your proposal. So this should represent the total cost for preparing and submitting your design competition proposal. We're very interested in seeing how much effort that you're really placing in there, and if you place a value on your time, what does that represent? The second step is developing a beta test unit. Can you estimate a pre-production model? In some cases, that might be an academic research and development project where you might have graduate research assistants working on this as a funded project. So again, tracking what you think their time would entail, expenses, hardware, travel, anything else that you can think of to get ahead of what it would take to create a beta model if you're going to develop a product or software or anything else that might have a pre-production effort. As far as production, marketing, and distribution, so you've developed a beta model, and now there's been some acceptance of the unit. What is it going to cost to bring the unit to market? So there you might want to look at what you would suspect it would take to manufacture your product, sales, installation, your assembly cost per unit. Don't forget marketing and sales, because somebody's got to sell your product to get it out there. And again, tracking or estimating expenses. So what is it going to take in terms of materials, marketing, sales, and distribution. So some guidelines on estimating tangible benefits. Operational safety. Will your solution potentially save lives or injuries or property damage? How is it going to do that? What kind of accidents are you going to prevent? Or what are you going to do to make it more efficient? So if there's mid-air collisions, runway incursions, those are some things that we'd like for you to think through. There's also some qualitative measures. Potential accidents prevented, lives saved. A rule of thumb would be a cumulative total 10 to 15 years. And you can use this data to supplement your SMS discussion, since a large part of that is what is it that you're providing that makes the environment around the airport safer, if that's your project approach. Quantitative measures, estimating the potential value of accidents prevented and lives saved. And I'll show you in the example how you can quantify that. Operational efficiencies is another area. Will your product save time, wear and tear? How is it going to do that? How much time versus what's going on right now, the status quo? Is it going to reduce delays, shorter distances, people's time, aircraft time, vehicle time? If you're looking at environmental interactions, the environmental benefits, will your product or project mitigate impacts? Again, quantitative measures might be preventing remediation or cleanups, reduce material usage, energy costs. Some of the qualitative measures is looking at the number of people or households that might be affected or benefit from your approach. You can also look at areas of impacted land. And then the fourth is the airport planning and management, the management efficiencies. Will your project save time to airport administration? How is it going to do that? How much do you think that's going to save in terms of man hours? You might have to estimate a value of what a person's time is. And again, qualitative measures. Is it going to make people's lives easier by implementing your solution? Let's talk a little bit about estimating qualitative and intangible benefits. Some proposals may not be able to provide measurable benefits, and we understand that. In those cases, at least there should be some discussion regarding what the anticipated qualitative benefits might be. These can include, but are not limited to, improving efficiencies and the travel experience for flight crews, passengers. It could also improve employees and their day-to-day operations, aircraft, baggage, cargo. It's really up to you to see if you can assess how you're improving over what is going on right now. Are you improving the quality of life for nearby residents, the community at large? Again, airport operations management. You're making it easier for them, or even air traffic control personnel. So pulling it all together. In some cases, a picture is worth 1,000 words. And rather than read through a narrative description of the costs and benefits, a summary table can effectively illustrate the same information. You should be able to provide a description of the major assumptions that you were using to prepare the information. But otherwise, consider just using a table to enumerate the costs and benefits and discuss the table as you go forward. So now I'm going to run you through an example. This is a project that you can easily see how the benefit cost guidance can be applied. So I just made this up. Maybe you guys are already working on this. Is what I would call a diffuse laser alert system. So the concept is to take laser technology to alert somebody that's about to transgress on a runway and prevent a runway incursion. So the way this would work is there's a diffuse laser light aimed at an aircraft or a vehicle that's about to create a runway incursion or some other hazard. There may be a sensor from an established airfield surveillance system that recognizes that something bad's about to happen and automatically triggers an alert prior to the incursion. So the alert could be the idea of focusing on a relative geographic area to a series of maybe servo-mounted laser lights that can swivel and shoot a series of flashing red lights to capture the attention of the transgressing vehicle or operator. And that obviously is without blinding him, so there may be some way of using the laser to just cut through and grab their attention. Let me run you through an example of how a benefit cost analysis might work. First off, the research and development of your alpha model, which is essentially the time that your team has spent putting the design competition proposal together. So say your time is worth $25 an hour. That may be something that you can add to the table to quantify just how much time that you've spent working on the proposal from start to the day you FedEx it for a submittal. Next off is looking at the development of the beta model. So in this case, you might have to estimate the amount of time that you think it would take to get your design idea to some form of workable prototype or some workable example of how your proposal might proceed as if it was going to be considered for marketing and actually selling this and making it available to the world. Again, looking at your time, you may look at what university charges for graduate research time. Also, if you have a faculty advisor, you might add those costs, plus again, all the hard costs, whether you have materials, you have lab costs, you might have travel involved. You might want to add those up as well. In our example, we use $50 an hour for the grad student's time, and again, adding some time for travel and hardware costs. You don't really have to get elaborate about this, but just that you've had some thought about it and maybe you've stated your assumptions. Looking next at, okay, so your product's going to go forward for production. Somebody's picked it up and maybe you're going to make them through the university, or you're going to outsource that. Trying to get a grip on exactly what that's going to take. So if you have a product, you're going to know what the materials are, and figuring out how long will it take to assemble the product or put the service together. Estimating those costs. If you look at it like a per unit rate, so in an example we use $500 per unit to add to the cost. Marketing and sales. In this case, you may have a sales rep that he works off of a commission or something. So in our example, we use $30,000 a year to get that going. And this guy is the specialist. He'll make sure that the people who could benefit from your idea is going to know where to get it from. Again, looking at your expenses for manufacturing, if there's materials, if there's shop fees, any tooling you might need. Going back to the marketing and sales, you're going to have advertising, you're going to be at trade shows, looking at those, and then distribution. So you're going to have to get your product to the customer, or in this case maybe the airport, so there's going to be shipping and installation. And in the example, we use $250 each to estimate that. So grand total for production, marketing, and distribution is going to be something like $140,000. And assuming that you're going to be producing 100 units, that works out to about $1,400 per unit that's going to cost. And hopefully you're going to build some profit and margin into that. And finally, looking at operations and maintenance. In this case, there's two areas to look at. One is if somebody is using your product out in the field, how much time are they spending looking at whatever your product might be producing or them using your product, but also technical support. So, in that first year, you may be at least making one trip out there to make sure everything's working okay, doing a maintenance trip to make sure that everything's running smoothly. Also, training is also involved with that. So in our example, we come up with a total of about $297,000. And again, if you look at $100 per unit per year, and remember what I said about maybe extending that out 10 years, that it works out to about $575 per unit per year to support the operation and maintenance aspect of your design idea. Shifting gears and looking at value assumptions. So, in the safety case, there's always a risk. There's a risk of an accident. Either it's an aircraft and another aircraft mixing it up, or an aircraft and a vehicle. We've made some basic assumptions, and if you want to do more research on that, that's fine, but just to get an order of magnitude feel for how much risk is out there, we can dissect this in the rate of maybe an accident per million operations. And in the example, we use 0.02 accidents per million for both the aircraft to aircraft accident and also the aircraft to vehicle. Operational efficiency, again, looking at the operations person that's out there, if he's saving time at a value of $50 an hour, that's something you should add up. If you think it's going to save a person, say, 10 hours per month, that value gets added into the benefit side of the equation. Some other value assumptions, and this is where it gets a little more serious, is what is the value of an accident that might have been prevented? Looking at a more serious side of the benefit part of the cost-benefit equation is the value of maybe a life being saved or an injury being prevented. The FAA actually uses, and actually the OMB, the Office of Management and Budget, publishes a number periodically that establishes an economic value of life. You'd be curious to know that your life is worth $9.1 million right now as a fatality that you can add to the benefit if you assess the idea that you're going to be saving lives. The value of an injury is about 10% of that, so about $955,000 per person for the value of a serious injury. An aircraft destroyed or damaged also has a value that you can add to the equation. In the example, we used 1.5 million, which is an FAA average for the fleet. Now remember, if you're preventing an air-to-air or a mid-air collision, that's times 2. For the aircraft damaged, about $230,000 to repair an aircraft that has serious damage. A vehicle, on the other hand, whether it's a construction vehicle, snow removal vehicle, or even an ops truck, we're using an average of $250,000 per vehicle, and the damage value would be about 10%. There may be some other items that you can identify, and if you can find those, that's fine to add that to the benefit side of the benefit cost equation. So in terms of a cost summary, adding up the costs for development and for operations and maintenance per unit, what we show in the example is that per unit, development costs about $2,100 per unit, and operations and maintenance about $2,975, for a total 10-year cost per unit of $31,000 $850. So looking at summarizing the costs, looking at 10 years of what the cost may be to support your unit out in the field. Development, as you divide that out by the number of units that you've produced and adding your research and development costs, could approximate, in our example, $2,100 per unit. Same way, and that's a one-time cost. For operations and maintenance, now again, 10 years out, you're looking at maybe $2,900 per year for 10 years. So that works out about almost $30,000 a year. So when you add that cost summary together, that is the cost for providing that unit out in the field. Now looking at the risks that are out there. So we're using, again, if you remember, the 0.02 accidents per million operations. A typical airport, busy airport, may run about 125,000 operations per year. So when you apply that rate per million, your risk potential over 10 years works out to about 0.25 over a 10-year period. So what that's saying is that over a 10-year period, your chances of having an accident is less than 1 over that 10-year period. The same way with the risk of an aircraft to vehicle accident, which may be a more likely scenario. So the risk assessment for that may be a little bit higher. So again, applying that same number of operations over a 10-year period times the risk factor could approximate 0.625 accidents per for your airport example over a 10-year period. So comparing the two, I would say the higher risk value would be the one that you would apply to your benefit side of the equation, because the risk is what you're trying to mitigate. You're trying to prevent that accident from happening. So when you do apply that, so in our example, we assume that there's one accident prevented in 1 year over 10 years. But that accident is pretty serious. So there's one fatality, 2 serious injuries. The aircraft and the vehicle, in this case, are both destroyed. Looking at the table, the value of the fatality applied to that risk factor is about $120,000 over that 10-year period. The value of the injury, coincidentally, is about that same number, so $240,000 in terms of the one fatality and the 2 injuries. The aircraft destroyed, again, averaging that over a 10-year period is only $75,000, and then the vehicle around $15,600. So when you add up all the accident costs that are prevented, it comes up to a number about $330,000 over that 10-year period. But if you remember, on the cost side of that equation, you were somewhere closer to $32,000. So when you divide the benefit to the cost, you're going to come up with a benefit to cost ratio of over 10. So what that means is that the benefit you're providing is more than 10 times what it's going to cost you. And therein lies the business case for your proposal. So let's talk about some tangible benefits. First off, operational safety. Will your solution potentially save lives, injuries, property damage? How is it going to do that? What types of accidents are going to be prevented? Are they going to be runway incursions, mid-air collisions? Qualitative measures as well. Potential number of accidents prevented, lives saved, even using a cumulative of over 10 years, 15 years. You can also use the data to supplement your safety management system discussion. Qualitative measures can include estimating the potential value of accidents prevented and lives saved. Operational efficiencies is another aspect. Will your product save time? Will it save wear and tear, maybe on vehicles and people? How's it going to do that? How much time do you think it's going to save versus the way things are now? If there are delays, are they going to be prevented? Shorter distances that people have to travel? There's people's time, aircraft time, vehicle time. So we realize that not every proposal is going to have tangible benefits, but maybe there are some intangible benefits that you can identify. In those cases, there should be at least some detailed discussion regarding what you anticipate as far as qualitative benefits. We mentioned this before, but those can include operational efficiencies. Are they going to be saving time? Do they improve the travel experience for passengers? Better mobility, easy to use. Those could be incorporated into your discussion as well. Managerial benefits. How does this benefit airport management or airline management or air traffic? Are we providing more data, better data, data collection? Environmental benefits could be an improved quality of life for neighbors around the airport, better surveillance of contamination risks. Again, those should be things that you can identify. Be sure to mention anything else that you can think of that justify why your proposal stands out from that perspective. So summarizing, benefit cost ratio is a means to demonstrate the business case for your product concept. In this case, we show that the product can save lives and there's a value to that. Others may save time. This example is to demonstrate the concept of the BC methodology. There are much more complex econometric models that can be developed, but for the design competition, simple is fine. If you use this example as a template, be sure to state your assumptions, your data sources, and anything else that you are providing. Again, we say that you should consider adding your business school's assistance for preparing this section, and they may be able to provide some insight into what you have and what you're proposing in terms of that benefit and the costs of providing the product or service. Okay, some final notes. The primary purpose of this section is to ensure that your design team has considered the economic factors associated with your proposal. In essence, you're addressing the business case for your solution. The design competition judging panels, we enjoy reviewing these proposals that demonstrate the creative talents that you guys bring to us, and we just want to make sure that you've considered the practicality of your work. You know, I've been involved with the University Design Competition for several years, and along with my colleagues, we're always excited when we receive the proposals and we start reviewing them and see the creativity that goes into the submittals. We hope that this information is valuable to you because what it represents is a way of quantifying the benefit. We understand that you spent a lot of time thinking this through, and we want you to also experience the idea of creating this business case for your ideas. You never know, it may turn into something someday, and you guys, some of you out there may get rich off of this, but this is where it starts. Somebody's got to come up with the idea, but going through this benefit cost analysis really helps you answer some of those questions that you'll invariably get. And again, think of the Shark Tank and you guys sitting up there pitching your ideas to these guys. That you've got the answers that you want to deliver to them to show just how valuable your idea is to the airport world.